thousands of years, the people of Earth have pondered the question, are we alone in the universe? We may one day find the answer by communicating with an advanced alien race. The history-making moment known as first contact.
You see this bright line here? That's a signal.
But could living, breathing aliens, or even intelligent machines, really make the long journey to Earth? Or if ET sends a message, will we recognize it when it comes? And what are the chances that we'll be the ones to find another civilization first and reach out to them? When it comes to communicating with other worlds, what seems like science fiction today may soon become science fact. Because first contact could happen to the human race much sooner than we think, and in ways we're just beginning to imagine. It's a question we've long pondered. And the favorite scenario of science fiction. Could living, breathing aliens really just show up on our planet one day? It's the wildest, most exciting, and scariest possibility in the world of first contact.
First contact refers to the moment when we humans, for the first time, gain some communication link to alien civilizations that have some means of communicating back to us. It's the moment when we finally engage in the great galactic country club of intelligent life. The search for technological life in our galaxy and in our universe is a spectacular quest, maybe indeed the greatest quest of all of humanity.
There's no doubt that a visit from an alien race would be an earth-changing event.
If you take a look at great milestones in human history, we have the discovery of fire, the discovery of agriculture, the discovery of writing and mathematics. However, if we make first contact, it tops all of that. The importance of a first contact ranks with the separation of Homo sapiens from the apes.
So what are the chances that we'll get to experience this history-making moment? The odds depend on how many advanced alien civilizations might be out there. And to get a handle on that number, researchers turn to a mathematical formula known as the Drake equation.
Back in the 1950s, scientists would speculate about what's out there, but there was no handle, there was no mathematical formula to refine our analysis. It was just idle dinner table chatter. Then astronomer Frank Drake had an idea. Why not try to quantify the probability of finding life in the universe?
Drake wrote down this very simple equation, which was just to estimate how many societies are out there in our own galaxy, forget the other galaxies, just in our own galaxy that are broadcasting signals that we might pick up, this afternoon.
The full Drake equation consists of 7 variables. In simple terms, this equation takes the total number of stars that could be in our galaxy. What fraction of those have planets? What fraction of planets have life? What fraction of those have intelligent life? And finally, what fraction of this intelligent life might be busy sending signals into space?
The first reasonable calculation showed that there could be 10,000 planets in our own backyard harboring intelligent life forms. And that created a problem. If there are 10,000 of them, then where are they? Carl Sagan then tried to look at the numbers again, and he came up with numbers like 1 million. And then it became embarrassing. There should be intelligent life forms scattered right in our own backyard that we see every night, but we don't make contact with them. So we had a problem. a problem that persists even to today.
With such high odds of intelligent life in our own galaxy, it makes sense to give some serious thought to one of science fiction's favorite scenarios. What would really happen if aliens all of a sudden showed up?
All movie buffs imagine that there must be elaborate protocols for a possible visitation. What do you do when a flying saucer lands on the White House lawn? What do you do when all of a sudden Moscow and all the great capitals of the earth have flying saucers over them?
If the government has a plan for this, they're not talking about it publicly. But even without a top-secret clearance, we know the types of basic steps that will take place. United States Air Force Strategic Command and scientific research groups are already on the lookout for asteroids that could impact Earth. And since they're able to spot asteroids years before they might hit us, one of these groups will see any type of alien craft headed towards Earth long before it arrives. So the government will have plenty of warning as long as the aliens can't hide their approach. Then, once in our atmosphere, jets are scrambled to escort these celestial visitors to a landing site where the event is closely monitored and controlled. If the aliens arrive over American airspace, then one location that fits the bill is Plum Island, off of Long Island, New York. This is where the Department of Agriculture has its Animal Disease Center to isolate and inspect for possible infectious diseases, because that's one of the biggest dangers when ET shows up. Then, scientists from the National Institute of Health and Centers for Disease Control will don biohazard suits to examine the new visitors. This is crucial to prevent the spread of disease either from us or to us.
If there were physical contact with alien races, what about disease? What about competing ecosystems? We already have a terrible problem all over the world with organisms fitted to one environment in Asia getting into the Mississippi Valley, or vice versa. These are already called alien organisms. So if there were physical contact, there'd be a whole list of worries.
And biological dangers aren't the only concern. The alien ship that's traveled here from across the galaxy has to have a propulsion system more powerful than anything on Earth. So Department of Energy scientists will also rush to the scene to check for hazardous materials. Getting into details of human-alien interaction is impossible. Have they come in peace, or are they here to wipe us out? And will we even be able to communicate with them? Since our celestial visitors' technology will probably be far beyond our own in order for them to make such a momentous trip, we may have much less control over the situation than we'd like to think. Regardless of all these unknowns, some scientists believe the odds of first contact are overwhelmingly in our favor, especially when we look beyond our own galaxy.
I think it is inevitable that we will have first contact. Take a look at the night sky. Every night, the Milky Way galaxy comes out with 100 billion stars out there. But how many galaxies aren't there? Believe it or not, our telescopes can see 100 billion galaxies in the night sky. You do the math. 100 billion times 100 billion, that's 10,000 billion stars in the universe.
That is the equivalent of all the grains of sand found on Earth. But this astronomical number of stars also brings up a very big problem. The distances between all of these stars. Is the enormity of space something that a more advanced civilization can overcome? Even if an alien race can master traveling at the speed of light, 186,000 miles per second, it would still take roughly 4.5 years to visit Earth from the neighborhood around our next closest star, Alpha Centauri. And since most stars are anywhere from hundreds to billions of light years away, the odds of a face-to-face visit begin to look very slim again. But physicists believe there might still be a way.
The principal objection is that the distance between stars is too great for its travel. However, let's say we have a civilization so advanced that new laws of physics begin to open up. Let's say we have a star located right there, and another star hundreds of light years away. For an advanced civilization, they may be able to warp the fabric of space and time and bring these 2 points right together and then punch a hole so that the shortest distance between 2 points is a wormhole, a gateway, a portal through the fabric of space and time.
A wormhole, although still only a scientific theory, could serve as an intergalactic shortcut between 2 points in the universe for alien creatures. But even if this kind of shortcut exists, there's no way to know if a living creature could survive such a trip. Does that mean our chances for a face-to-face visit are doomed? Not necessarily. That's because some theoretical physicists believe that the most likely form an alien visitor will take won't be a biological creature at all. It'll be a smart machine.
I actually think that once you get to a certain technological level, you invent machine intelligence. This, that's a good starter mode. It's a good starter intelligence, but very quickly you make thinking machines. Thinking machines aren't stuck with all the defects that biology offers.
And there's a unique type of intelligent machine that seems to have the best chance of pulling off the improbable journey to Earth.
It's a very reasonable theory that since our ability to explore with robotic systems is well beyond our ability to explore with people, that the same would be true of an alien civilization.
Machines travel in space far easier than biological creatures that need food, air, water, and everything. You can ship them from planet to planet, from star to star very easily.
Without the need for life support supplies, an alien civilization could send an extremely intelligent robot to search for life beyond its own cosmic backyard. Still, our universe, and even just our own galaxy, is too large for a single machine, or even hundreds of them to explore. It would take billions of years to travel to every star. But what if this machine was so smart that it could make copies of itself? And what if its descendants could do the same? Then, instead of one machine exploring the cosmos, thousands, and eventually millions of them could tackle the task simultaneously. This seemingly futuristic idea of an intelligent self-replicating probe was actually imagined here on Earth back in the mid-20th century by Hungarian physicist John von Neumann. A von Neumann probe would need to grab resources readily available in space to replicate itself, such as metals and gases found on asteroids, moons, or planets. So what would one of the... In the world of science fiction, alien machines that arrive on Earth are often huge and powerful, able to squash us like bugs. But if the von Neumann probe actually shows up, we may be the giants, and the probe may be the bug.
These could be very compact. They could have nanotechnology and circuits, nanocircuits that are made out of individual atoms. So every part of the von Neumann probe could have the power of a Pentagon supercomputer. So this device could store the entire information content of an entire planet.
Nanotechnology is the science of building fully functioning machines on impossibly small scales. From 100 nanometers, meaning 100 billionth of a meter, down to a fraction of a nanometer. For comparison, a single strand of DNA is 2 nanometers wide. This type of compact design offers several advantages over larger alien probes. Fewer raw materials would need to be gathered for replication. The small mass would make things easier on the propulsion system. And such a tiny visitor would likely avoid detection and unwanted attention. And the alien probe builders wouldn't need their technology to be too much more advanced than our own. After just a few decades of nanotechnology engineering, we can already build a functioning microchip smaller than a dust mite. So an impossibly small, smart, self-replicating probe would probably be a piece of cake for an alien civilization more advanced than humans. Especially since there'd be very few parts needed beyond the self-replication unit.
First of all, on the top of the von Neumann probe will be an array of antennas by which they can communicate which planets have liquid water, which planets have microbial life, which planets have intelligent life on them. At the bottom, we'll have some kind of propulsion system.
But when it comes to a face-to-face visit to Earth by aliens, there is a third option for first contact. It's possible that if an alien is able to make the long journey here, it may not be either a biological entity or a smart machine. Instead, it may be both, part flesh and blood and part machine. Something science fiction calls a cyborg. Theoretical physicist Dr. Michio Kaku believes we need only look in the mirror to see why a cyborg may be the preferred life form of an alien civilization.
Now let's push the fast-forward button. Let's start to go just on the Earth, 100, 200, 300 years in the future. That's just a blink of an eye. At that point, we may want to emerge with immortal bodies. If the choice is between death, between seeing our bodies decay and suffering like that, or waking up one day with a body made out of silicon, steel, and tissue, and living forever, which would you choose? And that's just for us. An advanced civilization a million years ahead of us may have options even beyond cyborgs and beyond robots. They may have options that we can only dream of today.
First contact. The moment when the human race finally comes into contact with an extraterrestrial race and discovers it is not alone. It's an event that could open up incredible new opportunities or lead to the end of life on Earth as we know it. If an advanced alien civilization does exist, and if it sends a signal across the cosmos to make first contact with us, then one of the most likely places that history-changing message would be received is this remote site nestled deep in the Lawson National Forest of Northern California. Here, the first dishes of what will become the largest radio telescope array in the world are already emerging from the rugged landscape. The sprawling complex is known as the Allen Telescope Array, or ATA. It's operated by the SETI Institute, a private non-profit organization which stands for the Search for Extraterrestrial Intelligence. Before, SETI scientists had to borrow time on other receivers to search for alien signals. Now their own dedicated radio telescope is up and running.
Now, you see these antennas behind me. There are 42 of them now. Each of them is about 20 feet in diameter. It's like a radio camera. It can take pictures, radio pictures on the sky with enormous detail because it's got lots and lots of these little antennas. It's like one giant antenna that's been broken up into small pieces.
In a few years, there will be 350 dishes, all working together to become the world's largest listening post for alien signals. At full capacity, the site will be able to scan 10 billion radio frequency receivers that SETI has used in the past. To interpret these signals, radio telescopes make multiple passes on one region of the sky, record the data they receive, and then convert that data into a mosaic image for analysis. So technically, the researchers are looking at, not listening to, the signals.
In the movies, they always put on a pair of earphones and listen for them, but You know, it doesn't really work that way in the real world. What actually happens is the signals come into this room. I mean, this is the mother of all radios, right? We're not listening to one channel at a time. We're listening to tens of millions. Now, of course, we're not going to sit here and look at this stuff. If we want to know whether ET's on the air, we're going to monitor that on a computer terminal, and those are over here. So this is where the astronomers sit in the control room. Every telescope has a control room. This one doesn't really look like the bridge of the Starship Enterprise, unfortunately. It's rather simple, but it's functional. You can actually sit here and look at the signals. The trouble is, when you have tens of millions of channels, there's really no way you can monitor them all anyhow. And it's kind of like watching paint dry, really. I mean, you can sit here days and days and days, you're going to go crazy, you know? So we don't do that. In fact, you let the computers do all the listening, let them wear the earphones. This computer over here actually is where you can give instructions to the telescopes. You can give them, as it were, a shopping list. First, I want you to go to that star over there and spend an hour observing that one. And then next, you go to another star on the list and then go look at that one. And they'll let you know if they pick up a signal that's really interesting.
Exploding stars and many other celestial events produce naturally occurring radio signals. And man-made objects in space also send signals home. These will be picked up by the ultra-sensitive ATA dishes and must be weeded out by the computers so they're not mistaken for an alien signal. Alien signals would stand out either by producing repeating patterns from deep space, areas where man-made equipment doesn't exist, or by dramatically amplifying naturally occurring radio static.
You see this bright line here? That's a signal. And it starts out at this part of the dial, this frequency, and then it moves up in frequency toward higher frequencies, right, with time. Well, that's exactly the kind of signal we're looking for. It's at one spot on the dial. It's a transmitter. And it's also moving up in frequency. We kind of expect that from ET signal because ET will be on a planet that's rotating. It'll do that. But it's moving so quickly in frequency there that that's clearly a satellite. Maybe a telecommunications satellite, maybe a space probe.
But as sophisticated as this new array is, it will only be able to scan a fraction of the stars in our galaxy over its lifetime. About 1 million out of the billions and billions of Milky Way stars. So where could ET be? And how will we know when a real signal comes through? The SETI team is confident they'll be able to spot any life-changing messages after a dramatic event. Green Bank, West Virginia, July 1996. Signals from outer space were being collected by the huge radio telescopes at the National Radio Astronomy Observatory. The researchers from SETI, the Search for Extraterrestrial Intelligence, hoped they'd be able to eavesdrop on an alien communication, confirming once and for all that we are not alone, the moment of first contact. Although it's a routine procedure, that day, something was different. The SETI team began receiving an unusual signal, a signal that created quite a stir. SETI scientists began to run through their predetermined protocols. Step 1. They moved the radio telescope dishes at the observatory slightly off target, then returned them to their original position. If the signal continued during this movement, then they'd know it's a false alarm from something close to Earth, like a satellite. But if the signal was coming from deep space, then even a slight adjustment to the dishes should cause the signal to stop, then return when the dishes are moved back. That's exactly what happened. The signal had passed their first test. Now for the second. Step 2 is contacting another observatory, preferably on another continent.
Call up somebody at a different radio observatory, somebody who has a different set of antennas, because you wouldn't believe it if you were the only ones to find it. It could be just a bug in the hardware or software here.
But 16 hours after the signal was first detected, and before they could get a confirmation from another observatory, they discovered the source. It was coming from the SOHO spacecraft, 1 million miles away from Earth, currently studying the Sun. A software glitch in SETI's computer system made SOHO's communications appear to be a legitimate alien signal. Despite the obvious disappointment, the event gave SETI Institute scientists confidence that their protocols work, and that when a true alien signal comes in, they'll be able to recognize it and realize that first contact is being made. But they still need to make sure that their dishes are pointed in the right direction, at the right time and at the right frequency, which is no easy task.
So where is ET hanging out? I mean, you know, we could point these things anywhere. Well, we don't know. Obviously, we don't know. But what you do is a very simple strategy. You start with the nearest star system and you sort of work your way out. Right? You start looking in your own backyard first. I mean, imagine looking for, I don't know, for fat elephants. You might start in your own backyard and work your way farther and farther afield until finally you either hit an elephant or you don't.
In the years to come, SETI hopes that new space-based technology and missions planned by NASA and the Jet Propulsion Laboratory will help pinpoint attractive targets. These targets are called exoplanets, planets outside of our solar system orbiting around other stars in the universe. But finding them is not easy.
To discover planets around other stars takes every bit of technology we've got. We use the biggest and fastest computers, and we use the biggest digital cameras you've ever seen. Some of them are 1 billion pixels, not a megapixel, but 1 billion pixels. So with all of that technology brought to bear, we are beginning to find these exciting planets around other stars that, frankly, remind us of our own solar system, of home.
But current telescope technology only allows us to see rough images of huge gas giants like Jupiter, which has a diameter 11 times larger than Earth. We can't yet see Earth-like planets, but that is about to change. The Terrestrial Planet Finder, expected to launch by 2020, will use multiple space-based telescopes, all working together to peer deep into the cosmos for an alien Earth, which might harbor intelligent life.
This would be a gargantuan telescope allowing us to take the first pictures of another Earth around a nearby star, a pale blue dot orbiting a yellow sun. Wouldn't that be glorious?
And the Terrestrial Planet Finder will provide more than just an image.
You not only can see if the planet is bluish, telling you there's water on the surface, the prerequisite for life, but moreover, you'd be able to analyze the light from that Earth into all of its colors, blue, green, yellow, and red, even the infrared, telling us the chemical composition of that planet. And the most exciting prospect is to find a planet that has oxygen in the atmosphere.
But until the Terrestrial Planet Finder system is ready in 2020, SETI researchers will simply have to hope that the stars they target contain a life-supporting planet nearby. Many first contact scenarios depend on much more advanced aliens using incredibly futuristic technology to either visit us, send artificially intelligent probes, or at least beam a big hello message from across the universe. In those situations, we'll just have to hope that they use that old movie line and say, "We come in peace." But what if the responsibility for making first contact falls to us? Are we up to the task? Since our astronauts have only reached the moon, and a manned trip to Mars is still an imposing challenge, the idea of humans visiting other worlds is still the stuff of science fiction. But we do have probes heading off into deep space right now. In 1977, NASA launched the Voyager 1 and Voyager 2 space probes to study Jupiter, Saturn, Uranus, and Neptune. They are now far beyond Pluto, at the very edge of our solar system, and headed for interstellar space. Voyager 1 is farther out, about 9.9 billion miles from the Sun. Farther from Earth than any other man-made object. Each probe contains a gold-plated copper phonograph record. Mathematical instructions on how to play the records are printed on them, along with diagrams of scientific principles that are likely to be understood by alien civilizations.
They actually had a medallion that had engravings with sounds of the planet Earth, sounds that you could hear, the location of the Earth in our sector of the universe. Basically, a roadmap as to who we are, what we want, and sounds we make, and our location.
The cryptic messages and basic formulas on the probes were chosen by a NASA committee shortly before the launches to give the best representation of the culture, people, and natural wonders of Earth.
As the Secretary General of the United Nations, I send greetings on behalf of the people of our planet.
Hello from the children of planet Earth.
Bonjour tout le monde. Mae Lakmia.
Shalom. Hola y saludos a todos.
But these communications also serve as an example of one of the greatest challenges of making first contact. There is no guarantee that they will even understand us.
In the same way that we were able to break the code of Egyptian hieroglyphics using the Rosetta Stone, scientists are faced with the challenge of finding a cosmic Rosetta Stone, something that will be understandable, serve as a universal language that both extraterrestrials and humans will be able to tap into.
The Rosetta Stone offered a passage in 3 languages, 2 forms of Egyptian and also in Greek. The stone was a breakthrough in decoding ancient Egyptian hieroglyphics, one of the languages on the stone. Since the other 2 languages were understood, they were able to decode the 3rd. Such a tool would be needed for extraterrestrial communication.
The usual starting point of an interstellar message, the sort of universal language, the basic building blocks, is to start with mathematical and scientific principles. It seems likely you at least need to know that 2 + 2 = 4.
Mathematics is uniform throughout the universe. I'm a physicist, and one of the greatest thrills I have is writing down an equation for the first time in history, and perhaps on the other side of the galaxy, perhaps there's an alien being writing down that very same equation.
So could the Voyager messages, now billions of miles from Earth, be the first cosmic Rosetta Stone making their way toward alien civilizations in the farthest reaches of the universe? At its current speed of 35,000 miles an hour, far below the speed of light, Voyager 1 would take approximately 100,000 years just to reach our nearest star, Alpha Centauri, 4.5 light years away. But it isn't even headed in that direction. So the Voyager probes are not good candidates for making first contact. But there is another way that machines of our own making could make first contact for us somewhere out in deep space. It's possible that the people of Earth will be the first civilization to build the von Neumann probe, the intelligent, self-replicating machine that could keep multiplying in order to spread across the cosmos. It is estimated that the computers here on Earth will surpass the thinking capability of the human brain by approximately 2050 and have the ability to process an unthinkable amount of information. At that rate, it makes sense that smart machines may be the ones to make first contact for us in the future. In fact, the groundwork for those types of machines is already underway, changing the ways we explore the cosmos.
There are several missions that are using artificial intelligence software right now and operationally on a daily basis. The Mars exploration rovers also have a form of artificial intelligence software on board. And specifically, that software allows them to look for transient events.
Transient events are things that pop up within a matter of seconds, making it impossible for controllers back on Earth to react to, since it takes about 22 minutes to send commands to machines on Mars. For example, dust devils, small tornado-like cones that race across a dry landscape, can quickly form on the Martian surface, just like they do in deserts on Earth. They're extremely rare on Mars, but sophisticated artificial intelligence software on board the rover can process each image that's taken and transmit only the ones that captured a dust devil back to Earth. So the rover is making decisions on its own. But any future machines that we send to other worlds will need to be much smarter. They'll need to be able to do everything by themselves, since it would take far too long to send commands from Earth to a machine explorer in deep space, even with the commands traveling at the speed of light.
The nearest star to us, Alpha Centauri, is about 4.5 light years away. Well, if we send spacecraft commands, they won't get there for another 4.5 years. So that spacecraft has to be so smart that it has to know what to look for when looking for another civilization.
But there are still other ways besides sending astronauts and probes for us to initiate first contact. Because we're not just listening for alien signals. We're already sending our own messages out into deep space. And it's a strategy that some critics believe will lead to the destruction of Earth. With the most advanced equipment in the world, listening for signals from intelligent alien life is slow and tedious. As a result, some scientists involved with the SETI effort don't want to wait for first contact. They'd rather initiate it. It's a process known as active SETI, and scientists have already started broadcasting messages in hopes that someone will receive the call.
The traditional SETI program is to eavesdrop, listen in on signals between alien civilizations in outer space. Active SETI wants to reach out. They want to advertise our existence. They want to say, here I am. They want to say, this is what our DNA looks like, this is what our body looks like. Here is our exact location among the stars of the universe.
Active SETI began at the Arecibo Radio Telescope in Puerto Rico. The dish is currently the largest in the world, measuring more than 900 feet across, the equivalent to almost 3 football fields. It's built inside of a giant naturally occurring sinkhole in a mountain. In 1974, a broadcast left this location with the intent of initiating first contact with an alien world.
It was a basic message written in a language of math and science that said something about what life is like on Earth. Started with a basic counting system, the numbers from 1 to 10, a brief description of some of the chemicals that are essential to life on Earth, a description of our DNA, diagram of a human being, picture of where we're located in our solar system, and then a picture of the telescope that was actually used to transmit the message. The only problem with that message that was sent from Arecibo is that if we get a reply, it won't be for another 50,000 years.
That's because the galaxy that was directly overhead and easiest to target at the time, known as M13, is 25,000 light years away.
In hindsight, looking back at the early attempts to advertise our existence to the universe, it was really not a coming out party at all. It was actually a feeble attempt, and these galaxies that we're trying to send messages to, they're up to 25,000 light years from the Earth. A round trip would take 50,000 years. Long after civilizations have risen and fallen on the planet Earth, perhaps a return message will come back, maybe a busy signal, we don't know. But I think it was rather naive of us back then to try to announce our presence, our coming out in the Milky Way galaxy.
Although there have been more recent attempts at sending messages aimed at much closer targets, active SETI programs generate a lot of controversy. Critics worry that sending a beacon advertising our existence may invite unwanted danger.
I think it is a miserable idea for us to advertise our existence without knowing the intentions of these alien civilizations. I mean, if you're a deer in a forest, are you going to blare out and advertise your location to the hunters who are out there? Let's wait and see what their intentions are.
Peaceful or not, scientists have begun ranking the technological capabilities of an advanced civilization in a range known as the Kardashev scale.
When we scientists gaze in outer space, we don't look for little green men. We look for type 1, type 2, type 3 civilization based on physics and energy consumption. A type 1 civilization is planetary. They consume all the energy that falls on their planet, and a mature type 1 civilization may begin to modify their weather. They may begin to have cities on the ocean. They may be able to control the power of earthquakes and volcanoes. A type 2 civilization has exhausted the power of a planet, and they are stellar. They play with entire stars. Type 3 civilizations are galactic. They roam the galactic space lanes in their starships. They play with black holes at the center of the Milky Way galaxy. They play with entire groups of star systems, and they consume the entire energy output of 10 to 100 billion stars.
To put it into perspective, Dr. Michio Kaku theorizes how Earth as it is today ranks on this scale.
We are perhaps 100 years from type 1. We're perhaps a few thousand years from being a type 2 civilization, and we're perhaps 100,000 to 1,000,000 years from being type 3.
Whether it's aliens showing up in our skies, or sending us a beacon from somewhere out there, or even if we're the ones who initiate first contact, there's no doubt that this event will change humanity and our view of the universe forever.
We could get an existential shock when first contact takes place. At that point, we'll realize that we're not king of the hill, that perhaps we share our universe with other intelligent life forms, and it could force us to question who we are and how we fit into this larger universe of ours. It could be an epiphany for us.
Since first contact could be our salvation by delivering advanced technology to create a better world, or the beginning of the end for the human race, it's no surprise that this dream evokes both wonder and fear. But despite the unknowns, there seems to be a primal urge driving us, a need to prove that we're not alone, a never-ending desire to make first contact.